so we can do it later. Okay, so last time we looked at the topic of generics, and hopefully you guys feel comfortable in your current assignment, meaning the one that I will give you today. You will not only develop a database solution like we discussed, you'll use the generic concept, for example, to convert a data table to a list of strongly typed objects. So this will give you good experience. The specifications for the assignment, I'll put it on the website. Okay? So later today, please check and you'll get the latest assignment, right? So the next topic that I like to briefly go over is file processing. So reading data from files, writing to files is a fundamental need in any, and we run into it in many scenarios, right? So how do we read data, write data to a file using C#? The answer is very similar to Java. If you've done Java, then you'll find it extremely similar. But even if you haven't done, at first it seems a little complicated, but once you get used to it, you will see it's very neatly designed and gives you a great flexibility, not only to be able to read data from a file, but also from a network socket. Okay? So the concept both in Java, both in C# is like this. Okay? If you have any I/O device, okay, for example, a file, okay, we don't try to read the data directly from the file. Okay? So if we wanted to read or write the data from a file, we go through one intermediate level. So we go through what we call a stream. Okay, so first thing is we associate a stream with a file or a network socket or any other input-output medium. Once we have associated the stream, then our code simply reads or writes using the stream object. Okay? The biggest benefit of putting one more level over here is that it makes our code independent of what the actual medium is. So for example, if it's a file, as long as we have a stream associated with it, since our code is only dealing with the stream, it will be, if it is working correctly, then if we change this to, let's say, a network socket, so take a look over here, since our code was still dealing with the stream, it does not have to change. So it basically makes it flexible so that any medium can be easily read from or written to. Okay? So the concept that you need to know now is there are different kinds of stream objects. Okay? There's a text type of stream. Okay, there's a binary stream. So, for example, what if the image, the file is an image file or multimedia file, right? So that would be a binary type of stream that we will need to associate with the file. If it is plain, comma delimited, tab delimited type of text file or a regular text file, then obviously a text stream needs to be associated with it, right? There's another kind called memory stream, where we use the file content and dump it into a memory before further processing with it. So a little bit later I'll show you the memory stream. Anyway, these two are very popular, so today let me at least cover these two. Okay. Now, easy way to remember, because if you go read a book or go to the internet, you will see both in Java, both in C#, there are dozens of different ways to read-write to a file, right? So that it's less confusing, I'll give you my guidelines how you should proceed. So if you can simply remember, if you use the plain stream class without any prefix or postfix, the plain stream class is a binary stream class. Okay. Then if you use a class called stream reader, this will allow you to read data from a text file. Okay, so this is a text type of stream, right? If you use a class called stream writer, it will allow you to write to a file. Okay, so for text type of reading, writing, you will use stream reader, stream writer. For binary type of reading, writer, you will use just the stream object. Okay. Memory stream we'll cover a little bit later. Okay. So our typical procedure for reading, writing to a file goes like this. Number one, create a file object. Okay, so in plain English, associate a stream with it. So again, if it is a text type of file, you will associate a stream reader if you wanted to read from it. If it is a binary type of file, you'll just associate a plain stream with it, right? Okay, once we are associating a stream with it, we will also specify, okay, whether we are reading or writing, or whether the file should already exist if we are writing to it, for example. Okay, for writing, if the file should already exist. So those type of options we can select. Okay. So anyway, the typical so this is in plain English, right? So now let me show you typical code. So there is a class called file info. Sorry. So we have two classes called file info and directory info in the .NET library, which allow us to explore a directory and pick up a file, and so that we can read or write to it. Okay. So here's a typical code. So you will say, for example, file info, fi equal to new file info, and then in the constructor you will specify the file name. For example, let's say c:'temp, let's say t1.txt. Okay. So notice I'm using 2 backslashes because remember, in a string, if we use 1 backslash, that means the tab, right? So if we literally wanted to say, no, this is not a tab, this is a backslash, then both in Java, C, C++, we use 2 backslashes, okay? In C# you have another option. If before the string, so we could have also said something like this: file info @ sign . So once you put the @ sign, that means treat backslash literally as a backslash. Okay, so if you don't put the @ sign, then anywhere you need 1 backslash, you use 2 backslashes, right? Okay, so anyway, so this is basically creating our file object or file info object. Okay, now we will associate a stream with it. So let's pretend this happens to be some simple file, you know, with some data. Let's say Bill Baker 1234 2.97. So pretend this is the first name, last name, ID, GPA, right? So same way, Sally Simpson 1235, whatever, 3.12, right? And so on. So we wanted to read this file, and our goal was to read each student data and then store it in our database. Okay, so let's pretend this was already typed in a file called t1.txt, right? So we'll start out by file info fi equal to new file info ctem t1.txt. Now we will associate a string with it, so you will say fi.open. Okay, so again, there are many variations of how should we associate a string with it. My suggestion is call the open and specify two parameters over here. Okay, both are enumerations. One of them will let you pick the whether you are reading or writing. One of them will let you pick whether the file should already exist or not. Okay. So once I go to the computer, I'll show you. Based on my memory, it's something like this. I think one of them is called file access. So this is the enumeration dot read, comma something file mode. And I may be wrong, so once I go to the computer, I'll double check as I use the IntelliSense. So file mode dot open, and you have other choices like open or create or something like this, right? So we call the open method, and we always give it two parameters. Okay, so if you give it two parameters, then this will return with the stream object. Okay, as I mentioned earlier, if we have the plain stream, what kind of stream it is? Binary stream. Okay, so now if you can remember one more piece of information, the stream classes in the .NET library, okay, use what is called a decorator pattern. So if we have time towards the end of the course, I'll explain what this decorator design pattern is. But if a set of classes implements this pattern, one of the benefits of this pattern is to change one class type to another type, you simply pass an object of one in the constructor. So for example, let's say to convert a stream object to a stream reader object, okay, we'll simply pass one in the constructor of the other. So for example, let's say you already have stream str equal to file.open whatever parameters you picked, right? Okay, so now if we wanted to convert it to a text type of stream, which as I mentioned earlier is stream reader, so our code will simply look like this: stream reader sr equal to new stream reader, and pass the binary stream, which is str in this example, in the constructor. Okay. So to convert one type of stream to another type of stream, all you have to do is pass it in the constructor of whatever type you wanted to change it to, right? Okay, so once we have, so our next code, as I mentioned, will be to try to convert it to a text type of stream. So stream reader sr equal to new stream reader str, right? Once we have a stream reader, now we have some very easy methods. From the stream reader, we have a read line method. Okay, we also have a read to end method. So anyway, if you wanted to read one line, each line, and then further process it, your typical code will go look something like this. You will say string, let's say s line equal to sr dot read line. Okay, so this will read the very first line, right? And then you will go into a while loop, while s line not equal to null. Okay, now you will process the line, whatever line you have read. Okay, and then you'll keep reading, so you will say s line equal to sr dot read line. Okay, so anyway, this will be our typical code which will simply go in a loop, keep reading line by line. Okay, then we can further parse this line into as many parts as we feel like it. So let me show you what our typical processing code will look like. Okay, so our processing code to process each line, let's pretend each line is separated by our tab as an example. So this is a tab delimited file. Okay, so once we have read each line, so here's the code to process each line. Okay. There's a split function available, and again very similar to Java, which can split any string into as many parts as we feel like it. Okay? So first we do is we create a character array of separators. So for example, you can say \t. So our separator is going to be our tab. So we initialize this array to just one character, which is the tab character, right? And then if we did, let's say, string parts equal to s-line dot split and pass it the separator array. So what it will do is it will break this line into as many parts depending upon how many tabs it finds. Okay. So in this example, automatically parts of 0 will be the first name, for example, Bill. Parts of 1 will be the last name, Baker, and so on. So now let's pretend if we created a student class, student s1 equal to new student. Okay, and now we can say s1 dot first name equal to simply parts of 0. s1 dot last name equal to, let's say, parts of 1. Okay, let's pretend the ID, which is the third field, happens to be an integer. So I remember this parts array is a string type of array, right? How do we convert a string to an integer? In dot parse parts of 2. Okay. And s1 dot, if the last column was GPA, if let's pretend our student class already has the GPA as one of the fields, then this will be double dot parse parts of 3. Okay, so once we have extracted all the columns from our text file and populated the student object, then all we have to do is call a method, let's say write student to database and pass it s1. And now you can write this method, which will basically start composing the SQL and write it to the database, right? So let me go to the computer, quickly create an example like this and show you how straightforward it is. Okay, so let me open one of our old projects that we had done in this class. So if I go File, Open, Project Solution. Okay, if I go to our Fall 2015 folder, so DB Test is one of the projects we had done earlier. Okay, so once we are in this old project DB Test, okay, for example, if I run it, get product. So if you recall, we had written some small database with product ID, product name, price, units in stock, and category ID, right? Okay, so if I take you very quickly to the database. It's the wrong SQL server. Let me go to that's also the wrong SQL server. Okay. Because I think this one I had created in the SQL Server 2014. So let me locate SQL Server 2014. SQL Server 2014 and launch the Management Studio. Okay, so while it launches up, let me go to the form. And suppose I make this bigger. Okay, and so suppose I go to the toolbox, add one more button. Okay, and let me call this BTN read student data. Okay, so basically we'll read the student data. Oh, sorry, in this case it's a product data. Okay, because the database I'm using is the products database, right? Okay, so in our products DB, if you take a look at my screen, you will see we have 5 columns: product ID, product name, price, units in stock, and category ID, right? So let me go and create a text file. So if I launch Notepad, okay, I'll create Okay, so some sample data over here. So let's pretend product ID is 1000, and I'll make it comma delimited. So instead of tab delimited, let me pick comma delimited. Okay, next thing is product name. So let's say it's calculator, comma. Next thing is price, suppose 45.5. Comma, next thing is units in stock, let's say 25, comma. Next thing is category ID, I forgot, I think we had said 10 to be electronics as an example, right? So 1001, suppose it's smartphone, comma, let's say 359.95. Comma 45 is the stock level, category ID is 10, right? So let's say 1002, let's say TV, comma, price, let's say 695.50, stock level, let's say 12, category ID 10, right? Anyway, and for the last row, let me just hit the enter. So this will be our text file. So now if I save it, file, save as, and let me go back to our C drive, to our CS555, CS440 fall 2015 folder, and let me just call it product data, and it will be TXT, so the extension will automatically be given as TXT, right? So once I save it, now let's go to our Visual Studio. We'll write the code to read the file. So this button that I just added, let me make this text property of read product data. Okay, so let me make this wider. Okay, so now if I write the event handler for the product data button by double clicking on it, right? So we'll start with try catch exception EX. Okay, and if there's an error, we'll display the error. So message box.show ex.message. Okay, so now in the try block now, let's try to read the file, right? So as I mentioned, we'll start out by saying file info. File info is class declared in a certain namespace. Since we don't know what that namespace is, if we right click on it, if you're using Visual Studio 2013, it will give you the resolve option. If you're using 2015, it will give you the quick actions, and then you can resolve it, right? So I'll just resolve to system.io. Once it changes to light blue color, so now we can say new file info, and I saved it in CS440 fall 2015, and what did we call it? Product data.txt. Okay. Product data.txt.
It's case insensitive, right?
Case insensitive. So yeah, even if I type lowercase, uppercase for the file name, it will still work. Okay. So anyway, now as we discussed, we will try to associate a stream object with it. So stream str equal to fi dot open. Okay, so again, if we go to the IntelliSense, see, this is what I was talking about. Even though you have 3 options, okay, pick the one with 2. And if you make it a habit, you'll never be confused. Any kind of file processing, you'll be easily able to take care of it. So you can see there are 2 enumerations over here, file mode and file access, right? So if I go file mode dot, so what should I pick?
Open.
Because we are trying to read from a file, right? So it has to be open, comma. Now let's go file access dot, and what should we pick? Read, right? So it's very intuitive. Anyway, so once we have associated a stream object, what kind of stream object have we associated with it right now?
Binary.
Text or binary?
Binary.
How do we convert binary to a text? Pass it in the constructor of a text.
Stream.
So if we, text type of stream is called, if we are reading, is called stream reader. SR equal to new. After the new, always make a habit to hit the tab key, so it will automatically select and type it for you. Okay, and then str. So that will convert binary stream to us, right? So then, as we discussed, we will create a separator array. So character seps equal to, and what will be our separator character? Comma. Okay, now let me do string s line equal to sr dot read line. So this will read 1 line, correct? And now we can go in a loop while s line not equal to null. And okay, and now start processing each line. Okay, so we will do string parts equal to s line dot split. So we'll call the split function, give it the separator array. And so this will create as many parts as it finds in our each line, right? So if we go back over here, how many parts are there? 1, 2, 3, 4, 5 parts in each line, correct? So now let's create, so we need 1 class representing a product. Okay, so let's go and add a class. So if I right click on name of the project, say add class. Okay, so if I pick add class, oops, I forgot to name it. No big deal. If I right click over here, refactor, rename, and call it product. Okay, apply. And now I should rename the file as well to product. Okay, so we need 5 fields in this class, so I will say int, so public int product ID get set, public string product name get set, right? And what was the next field? Public decimal price get set. Because in our database we declared the data type to be money. Money translates to a decimal type in C#. Okay, and next one was public and what did we say? Units in stock, I think. set, and lastly public and category ID get set, right? Okay, so once we have created a class representing the 5 fields corresponding to our table, now let's go read the data into one object of the product class. So if I right click on form 1, view code. Okay, so this is where we were writing the code. So now let's create one object of the product class. So product PR equal to new product, and then PR dot product ID equal to parts of 0, correct? Yeah. And because product ID was declared int, so I have to do int dot parse. Okay, PR dot product name equal to parts of 1, correct? And PR dot, let me double check I'm matching the columns correctly. Product name, then next one is the price, correct? Yeah. So PR dot price equal to decimal dot parse and parts of 2, and then PR dot what was it, units in stock equal to in dot parse parts of 3, and lastly PR dot category ID equal to parts of 4, correct? And now we can call our function. So let's say add product to database and pass it the product, right? We'll write that in a second, so let me comment it out for right now. Okay, and now don't forget, since we are inside a while loop, we have to update the S line, otherwise you'll end up creating an infinite loop, right? So S line equal to SR dot read line. So now we will read the next line and so on, right? Now, sometimes what happens is if you are reading, processing a file, right? So let me go back to this file. Okay, unintentionally you may put a blank line. Okay, so what will happen? It comes to this line. It will read a blank, and then it will try to split it into 4 parts. Obviously, there are no 4 parts, so you'll run into an exception, right? Easy way to take care of that is, as you are trying to split, right? First check is it like an empty line? So you can always say if sline dot trim. So there's a trim function which basically will eliminate the blank spaces before and after. So if sline dot trim equal to just blank, then what should we do? Simply continue. So continue means go to the next loop. So we'll skip over any blank line that somebody might have put intentionally or unintentionally, so this will be a little more reliable as far as reading of the file is concerned, right? So let me run it through the debugger and see, are we able to read the data correctly? So in fact, let's do this. Let me do this. Okay, first let's run it to the debugger. Okay, so I'll put a breakpoint by clicking in this gray area over here, right? And if I go debug, start debugging, okay, we have some errors. Okay, I forgot one more end curly brace over here, so let me run it again. Okay, let me exit out one more time. The last copy was running, so I'll close it and close it one more time, and let me run it so that it runs the latest code. Okay, so once it runs the latest code, if I click on read product data, so it stops at the breakpoint, right? So let me put my mouse on S line. Is it reading the first line correctly? So you'll see 1000 calculator and so on, right? Now we can step through. So if I go F10, 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 F10. So now let me put the mouse on the product and expand it. So you'll see it has read all the fields correctly, right? So anyway, if I go debug, continue, and I can take the breakpoint out. So it will run through. So we know at least it's reading the data from the file correctly, right? So now what do we have to do? We have to write the code to add this product to our database, right? So now we have two possibilities. Remember in our database, if you recall, the product ID is a primary key, okay? So what will happen if we try to insert a product that already exists in the database? It will throw an error, right? So we should be checking to see if the product already exists in that database. If it already exists, what should we do? Should we still insert it?
No, skip it.
Should we skip it, or should we update it?
Maybe you need to update it.
We should do an update, right? So if you recall, when I was showing you this example some time ago, we already had created this data access class, which is implementing the iDataAccess function, right? So iDataAccess function, so with three things: get single answer, get many rows, and so on, right? Okay, so it is always a good practice because as you are creating a large application, you'll be composing many different kinds of SQL, okay? Rather than going to the button handler, so for example, going over here and us writing the SQL right over here, right? Which we could do, it will work, but that's not considered a clean implementation. So let me briefly talk about what's the good programming practice once you have the database code, you have the user interface, and so on. How do we...
Turn it up?
Yeah. For some reason, the blue is kind of hard to remove. Okay, so once we create an application, right? Here's our database, and as you guys saw, first we write the data access class, and we write all the fundamental functions that we need in interacting with the database. For example, in our case, there are 3 of these, right? Get single answer. Okay, get many rows, columns, correct? Each one of those takes a SQL as an input and replies back with, for example, get single answer gives us an object back, get many rows, columns gives us a data table back, right? And insert, update, delete gives us an integer indicating how many rows are modified, right? Okay, so in a proper design, okay, we need to compose the SQL before calling one of these functions, right? So what we do is we create another class over here, which is often called repository. Okay, so purpose of this class is, and we can define an interface iRepository before we write this and describe all the methods that we need over here. Okay, sometimes as the application becomes bigger and bigger, rather than writing one giant repository class, we break it into different classes. For example, anything related to product management could be in a class called product repository. Anything dealing with user authentication, updating somebody's password or so on, could be in another class called repository authentication as an example, right? So in the beginning, we start out with one class, but as our application grows, we refactor our code and organize it into smaller, more meaningful classes, right? Okay, so for right now, keep in mind what's the purpose of the method over here. Each method is to compose SQL and call the data access to get the job done as far as storing or retrieving data from the database is concerned. So that's the purpose of the repository, right? Then as we go further, we often have some business rules involved. Okay, so for example, okay, let's pretend you are creating some kind of product management or sales application, right? In a sales application, somebody will try to purchase a product, okay? And suppose if they purchase an amount greater than $100, you will give them a 1% discount. If they purchase more than $500, you'll give them a 2% discount, right? Okay, so rather than, again, hard coding all of those in the repository, these rules, because these rules change. Tomorrow, you may run a promotion. Let's say the holiday season is coming, and you wanted to increase it from 1% to 3%, just up to, let's say, December 25th. Then after that, you want to reduce it again. So that we can easily change our rules. All these additional discounts will be programmed in our business rules class, okay? So then the next layer over here is our user interface layer. So this is where, for example, our menu handlers or button handlers exist. So you click on a button. For example, in our current example, we wanted to upload a file, upload product information to the database. So even though for uploading something to the database, there's no rule involved, right? There's no discount, you really can't think of any rule. Should we, in that case, skip this layer, skip the business rule layer, and the button handler should trigger the repository?
No.
Okay, you could do that, you could make it work. However, as far as clean architecture or better programming practice is concerned, we never skip a layer. Because today you may say, oh, I don't need any rule. Tomorrow it may change. So even if there's no rule needed, you will still write sort of like a dummy function over here, or a wrapper function which will pass the exact same thing to the next layer. So never skip a layer. You always go from UI to the business, to the repository, to the data access, and it makes the entire architecture a lot cleaner. For example, tomorrow we have to change some of the business rules. Where will we go and change our code? in this class. Okay. Tomorrow somebody adds one more column to the database for our products. Okay. So let's say they wanted to also add a supplier ID to each product. So where will the changes occur in our code in that case? Only the repository. Remember, this simply takes the SQL. Where are we composing the SQL? Here. So changes become localized. So that's one of the benefits of this architecture, right? So today when I put a current assignment for you guys, you will create not only a proper layered solution related to product management, or it could be student registration or whatever, either way. So whatever I give you, you will create these layers and then create the proper implementation, right? Okay, and by the way, when we break this into different layers, this concept is called, so very briefly, there's what's called the design principle. Okay, and let me briefly mention one of the design principles that's followed in software industry quite a bit these days is called SOLID, S-O-L-I-D. Okay, what does S means? S means single responsibility principle. Okay, all it means is a class should only do one thing. Okay, so for example, if there's a user interface layer class, it should only deal with interactions of the user. Okay, it should not try to implement business rules. It should not have any database code over here. So each class is responsible for one kind of thing. Okay, for example, what's the purpose of the business rules? Class only to implement business rules. It has no knowledge of user interface or database or anything, right? So this layered architecture helps us implement the SOLID principles, right? O is called open-close principle, also called list-of substitution principle. And we discussed this in the last lecture, if you remember, right? And what does it mean? A class should do its own actions. It should not ask somebody else to do some work on its behalf. Okay. So already once we created the what did we call that? Populate row or method or get list.
Set field.
Set field. But what was the name of our generic method? Get data list or something, or anyway. So once we wrote that, that was already following the open-close principle or list-of substitution principle, right? Okay, so O is the open-close principle, L is the list-of substitution principle, so they go together. Okay, I is the interface segregation principle. Segregation. Okay, so what that means is, again, just like we were talking about, in the beginning you may only have 3-4 methods in the repository, but over a period of time as it starts to grow, we don't put, for example, more than 10 methods in an interface. If the interface grows, we break it into smaller interfaces such that each interface only has, let's say, 3 to 5 methods maximum. Okay, typically around 3 methods we put in an interface, right? Again, so what it means is, as a class or the interface becomes bigger, refactor it into smaller, meaningful interfaces. Okay. D is the dependency injection principle, okay, which basically means use loose coupling between layers. don't hard code the name of one layer into another class so that if this needs to talk to this one, if we hard coded the data access object, what if tomorrow we wanted to replace it with a small test data just so that we can individually test it? If there was a loose coupling, then this will allow us to test in an easy manner, right? So a little bit later, I'll show you how to accomplish the loose coupling. But bottom line is, these days, regardless you are creating a web application, or regardless you are creating a Windows or a desktop application, you should, or regardless you are creating a mobile application, always follow the solid principle. Okay, divide it into layers. Especially the single responsibility is very important. Don't try to write all code in just one event handler. Okay, so now let me go back to finishing this. Okay, so now let's try to write remember, where are we writing this code over here so far? We are writing it in
The button handler.
which is which layer?
User
User interface layer, right? So user interface will talk to which layer next? Business layer. So let's create one more interface first. So if I right click on name of the project and I say add new item, okay, pick an interface, and let me call this interface iBusiness product. So this is related to our product management. So it's hard, oh sorry, did I type I? I did not type I. Okay, capital I. The convention in C# is, if it's an interface, give it a name starting with capital I. So let me put it on a... Okay, so anyway, it's iBusinessProduct.cs interface. So once I click, that's the interface, right? So let me add, gradually we'll keep adding more methods to it, then we'll refactor it. Okay, one of the methods that we need over here is to, remember in an interface we don't say public or private. Okay, it's the class that implements the interface will decide on that method being public or private. So we will say bool add product. Or we can call it add or update product. Okay, always a good idea to pick a meaningful name. So add or update product, and what will be the parameter to it? Object of the product class, right? So product PR. Okay, so once we have written this interface, and gradually we can add more methods to this interface. Now let's create a class called business layer. And also what you will see is over a period of time we'll get, our project will grow and we'll get many, many classes over here. Okay, always a good idea to create folders and put the related code in those folders. Okay, so for example, to create a folder, all you have to do is right click on the project, add new folder. Okay, so suppose this will be our data layer. So once I have created a folder called data layer, I can simply drag and drop iData access into the data layer folder. I can drag and drop, what else did we write? Data access into the data layer folder, right? Okay, repository, we haven't written the interface that we wrote. Let's create another folder called business layer. So if I right click, add new folder, and let me call it business layer. Okay, and now I will drag and drop, where is business product into the business layer. Okay, so this way you can minimize these layers, and it's easy to see where to find a particular class that we need to update, right? And the neat thing is as you drag and drop any class into a folder, code-wise there's no change needed. Unlike Java, where folders are strongly tied to package names, C# doesn't care. So if you drag and drop, you'll run the project, it will still run correctly as before. So no code change needed, okay? So it's simply a reorganization of the files, okay? So now we need to create a file called, or a class called business product, right? So if I right click on business layer now and say add class, and now if I pick business product and click add. Okay, so now inside the business layer we have two classes, right? Now we can say business product. And if you recall, to implement the interface, all you have to do is right click on it. From quick actions, if you're using Visual Studio 2015, you'll pick implement interface, and it will end up writing the method, right? Okay, so now business layer is supposed to talk to which layer? Repository. So now let's create another folder before we write this code. Right click. First let's add a folder. Add new folder, and let's call it repository. Okay, now if I right click on repository and say add new item, pick a class. Sorry, first I need an interface.
We can still use class.
Okay, it's not giving me an option. Let me just double check. Yeah, we can use a class, but let me see. C, D, E, F. Yeah, there's an interface. Okay. So we can do repository or business repository. Okay, so business, did I spell it correctly? Business repository. Okay, so first we add an interface. Okay, so again, the signature will be similar to our business layer. So we will say bool add or update product and product PR. Okay, and now in the repository layer, let me add a class, and this will be business repository. Okay, business repository. Okay, this will implement which interface? iBusiness, sorry, not iBusiness. Business repository, right? Okay, so anyway, right click, implement interface. Now let's write this code first, and then we'll work backwards and write the business layer code, right? Now the repository needs to talk to which layer so that we can put this information in the database.
Data access.
Data access, right? So if we go data access, IDAC equal to
Data access.
data access. Okay, so now this is called strong coupling. Okay, next time I'll show you loose coupling. By strong coupling, because we are hard coding the connection between the repository and the data access by naming the name of the class, right? Next time I'll show you the dependency injection and how do we do loose coupling between two layers or two sub-layers. Anyway, for today, let me make it underscore IDAC, which typically, I mean, programmers, if it is a class level variable, will use underscore sometimes. You don't have, or let me just leave the underscore, doesn't matter, IDAC is fine. Okay, now let's go try to write this code. So try. Catch exception EX. Okay, and because this class related to a user interface?
.ex.
It's not related to a user interface, right? So if there's an error, we will not do messagebox.show. Instead, we will send the error back to the caller, right? So we'll simply do throw. Okay, now let's compose the SQL. Okay, so there are two possibilities, right? The product ID already exists in the database, okay, or the product. What we can do is if we go back to, let's say, iRepository, iBusiness repository, let's add one more method over here. Bool does product exist? Okay, and what should it take as a parameter? Product ID. So this way we can reuse this method in the beginning, call this method and see if it's already exists, then we will do the update. Otherwise we will do the insert, right? Okay, so now going quickly, so let me go 2-3 more minutes. If I go to the business repository now, since I've added one more method to the interface, I'll right click on iBusiness repository, implement interface, right? So now first let me finish this part. Does product exist? Okay, so again we'll do try, catch, exception EX, and simply throw over here again, correct? And string SQL equal to select product ID from products where product ID equal to plus product ID dot toString, correct? Okay. So once we have composed the SQL, remember our data layer, data access layer, which we already have a reference at the top called IDAC, if you take a look, right? So through IDAC now we can say bool ret equal to IDAC dot, IDAC dot get single answer and pass the SQL. Sorry, this returns an object, not a bool. Okay, and now we can say, let me create a return over here. Bool ret equal to false. And if obj not equal to null, ret will be true, correct?
Yeah.
Else ret equal to false.
No need for that.
Say it again.
No need for return.
Actually, it's a good practice to do that, because tomorrow if somebody commented it out or removed it, then so anytime you are making an actual decision, don't rely on some initialization in the beginning. Okay. Anyway, so return RET, right? So so now we can continue with this next time, and hopefully once you see how the full architecture is put together, then I will give you a nice meaningful assignment.